Okay, for this video, what we're going to do is start to process some numerical data, and we're going to throw this numerical data into what we call a frequency table. Okay. Now, recall that numerical data is collected by either counting something, so counting how many instances of something happened, for example, number of cars in a car park, or number of students in a class, something like that. Measuring is done well by measuring. Okay, so what we might look at is height of students in 10D versus height of students in 10C, for example. And then depending on the range of values for the data set, what we can do is set up the frequency table as either ungrouped, if we have a narrow range of values that occur, okay? And an example of something that would have a fairly narrow range of values would be something like, say, number of family members. So talking about your immediate family there, okay? So you might have 3, 4, 5, 6, 7, maybe out to 10, 11 maybe, if you're quite a large family, 12 perhaps, but it's still a fairly narrow range of values. Whereas if we have this really wide range of values, and I'm thinking here like heights of students rounded to the nearest whole number, you might get someone like at 150 centimetres through to someone who's like 176 centimetres. That's a fairly long or a fairly large range of values, or a wide range of values. So height of students rounded to nearest whole number. All right, so this first example here is ungrouped data, because what we have is a narrow range of values. And what we're doing is we're collecting data about the number of children in the families of 23 students in one homeroom, okay? So here's the list here, okay? And what we've got here is children in family, and we're going to put the number of children in the family in sequential order, and we're not allowed to skip any values. So here's what I mean. So our lowest value clearly is 1, so we're going to pop that in. Number of children in the family is 1, then it's 2, then it's 3, 4, and 5. Now, I didn't even note whether there was any 4s there, but we still need to pop in a 4, even if there isn't any, because that tally then will tell us that there's 0 4s, and that's really important to know. All right, so now let's process this list by getting a tally, okay? And the tally is usually done when we haven't got the data already. We'd be doing this live, so we'd set this up and you would move around the class of 23 students and take the tally, and then later on process the frequency. But we've actually already collected the data, so we're going to cheat a little bit and just put our tally in, even though it would be a redundant move. Right, here we go. We got 1, 2, 3, 4 ones. So we've got 4 of them. Now we're going to go to 2s. 1, 2, 3, 4, 5, 6. 6 of them, I think. 3s, we've got 1, 3, 4, 5, 6, 7. 7 of them. 4s, 1, 2, 3, 4. And it looks to be 2 5s left over. All right, let's just do the error checkings. That's 4, that's 6, that's 7, that's 4, that's 2. Add these up and it should equal the number in the question, 17, 21, 23. It does indeed. All right, now what we're going to do is look at the percentage frequency, and that's the, in terms of this, we would say of the 23 people in one homeroom, what percentage of families have one child, okay? So to do that, what we would do is it's 4 relative to the class of 23 students. And we're going to convert that to a percentage by multiplying by 100 and probably round that to a specified number of decimal places, even though this question doesn't say to do it. So we're going to go to, say, 1 decimal place. Now, again, the question should tell you how to round it. Okay, 6 is going to be 26.1. 7 is going to be 30.4. That one there is going to be 8.7. And that one is 4, which is the same as this one, which should be 17.4. And when I add these together, in theory, it should equal 100. It may not because of rounding, okay? So if it gets to 99.9 or 100.1 or 01 or something like, or 100.1, then that's okay if you've rounded to the specified number of decimal places, okay? So don't panic if it doesn't actually add to 100, but do panic if like you add the percentages together and you get 80. Okay, that's of concern, obviously. All right, so that's our first frequency table here. Let's go a second one here. There's times where we'll need to group the data because the range of values is really wide. And you can see here that we're looking at uni participation rates, and the lowest value is 1, the highest value is 55. And if I went with an ungrouped method, we'd have to go 1, 2, 3, 4, 5, 6, etc., all the way down to 55. And it would really create the world's worst or the world's longest frequency table. So what we're instead going to do is pop this into some grouped data, or pop this into some ranges. Okay, so our participation rates, we can see here that we want, and the general sort of guide is 5 to 10 sort of groups would be appropriate. Any more than that, and it's becoming too stretched. Any fewer than 5, and it probably doesn't create a very good graph that you can make decisions on. So we've got 1, 2, 3, 4, 5, 6 different groupings that we can use. So what I'm going to do is group them into like roughly groups of 10. So 0 to less than 10, 10 to less than 20, etc. Now we use this approach here, less than 10, to basically keep the numbers between 0 to 9 in this column here, or in this range here, 10 to 20 in 10 to less than 20. So this will be, for this particular data set, 10 to 19. And it just means that everywhere has a place. Now, some students, when doing this, go 0 to 10, 10 to 20, 20 to 30. And the problem is that if you get a 20, which grouping does it go into? Okay, so that's how we're going to group these. So I'm going to say 0 to less than 10, 10 to less than 20, 20 to less than 30, 30 to less than 40, 40 to less than 50. Geez, isn't it? 50 to less than 60. All right, now I'd have to process this list, and I find processing lists of unsorted data a nightmare. Okay, so here's a good early tip on the calc. So I counted earlier, I know that there's 23 places that we're talking about here that have got these uni participation rates. So I'm just going to type in all of that data into my calculator. 20, 36, 1, 25, 26, 13, 9, 27, 30, 1, 15, 21, 7, 8, 22, 3, 37, 17, and lastly 55. Now notice here that I've probably typed that incorrectly. I mean, you may have seen me make an error, but I don't think I did. But notice how the 23rd piece of data is 55. So this is the number of the column on your calculator. All right, so a really handy feature is this one here. We're going to go Edit and Sort Ascending. So what that does is it's going to ask us which list has the data that we want to sort. So we're going to say Sort Ascending. I want to sort one list, please. And that list is indeed list 1. And what it does is it just makes the numbers, or gives us the numbers in order smallest to largest. And it's really going to be a lot easier to process this list of numbers rather than fumbling around with this list up here. All right, so 1, 2, 3, 4, 5, 6. 6 numbers are between 0 to less than 10. So we've got 1, 2, 3, 5, 6. Hang on, 1, 2. Did I do that correct? There's 4, 5, 6. and 10 to 20. So that's going to be 4. Notice that 20 belongs to this grouping here, not to this grouping here. That's less than 20, the earlier group. So 1, 2, 3, 4, 5, 6, 7, 8. So that's going to be 8. 30 to less than 40. That's going to be 0 and important to include it. And 50 to less than 60 is just that one place. Right, so let's count 18, 10, 18, 20. What's going on here? I've got 22. Okay, let's do that count again. 1, 2, 3. Yeah, that looks right. So 8 for the 20s. Didn't go high enough. 1, 2, 3, 4, 5, 6, 7. All right, that's annoying. But it's a good example. I'm definitely going to leave that in the example here because what it shows you is the error check is that your frequency should add to the total number of things. And in the VCA Further Maths course, they always give you the number for the exam question as well. So that's 23. They'll tell you that so that you can error check. So that's going to be 11, 19, 22, 23. Right, now let's do that conversion again to percentage frequency. So we're going to go 7 over 23 multiplied by 100. And that one is, we're going to go to 2 decimal places. No, let's go 1 decimal place. So I'm going to write out my working for the first one. And then let's proceed. So 4 is 17.4. I think we did that one in the last example. 8 should be double that. So that should be, what's that? 34.8. 100% on that. I'm just going to check it. Yep. 3. 13.0 and 1. 4.3. Okay, so we're going to add these together and it should add to 100, but I think this might be a case. I've done this example before where it doesn't. Yeah, it doesn't. That's okay. So we're just going to say that the total is 99.9 cents. And it didn't add to 100 because we rounded those numbers, and that's okay. I mean, that's just what happens. I'm not going to list that to 15 decimal places to try and get it to add to exactly 100%. So there you go. That's the set of grouped data or grouping data for a frequency table. And your work for the first part of this period will be to complete worksheet 1. That's page 2 of that. And there's a select few questions from 9A.